So, good afternoon, everyone. I am Vishal Patil, product specialist, working as a product specialist in Scope TNM Private Limited. I am looking after for the cable fault location products in this organization. So, Scope is providing the testing and measurement instruments since last 30 years. So Scope is also manufacturing the cable fault location instruments. So now today we will see one by one how to locate the cable fault. So first we will see this is our agenda. First we will see what is power cable, its different types, construction and applications. And then one by one we will see what are the different causes of the faults which are occurring in the cable, and then we will see one by one what are the different types of faults in the cable, and then according to that types we will see the step by step how to locate faults in the cable. So this is the all over about agenda. Then we will see what is the exact solution the Scope is offering. So let's start. So first we will see power cable. The power cable mainly used used for the transmission the power in underground applications. Mainly the underground power cables are very useful in densely populated urban areas, because nowadays smart cities concept is widely opted by the India government. So that's why mainly the power is transmitted through these cities through underground only. Also, the underground power cables are very useful in factory operations, and where the overhead lines are very inconvenient for use. So that's why to transmit the power where the overhead lines are not feasible, we are using the underground power cables. Now we will see what are the different types of power cables. So power cables are mainly categorized according to the three types. First one is based on the construction, another one is based on insulation, and third one is based on voltage. So based on construction, the cable is mainly categorized into belted, screened, separate lead sheath, the combination of screened and separate lead sheath, and last type is the pressure cable. So belted cable is mainly used up to the 11 kV max to max 11 kV applications, where stranded core is belted with the impregnated paper, and then it is filled with fibrous material. So these type of cables are widely undergoes to the tangential forces due to its weaker insulation. So that's why this cable is mainly undergoes to core short circuit fault. So that's why these cables are mainly used for LT applications. Next type is the screened cables. The screened cables are mainly the core means conductor is insulated with impregnated paper, and then aluminum foil is surrounded around the conductor, and then a copper fabric tape is wounded around that aluminum foil, and these all screens are connected in contact with each other. So these screens are contacted with each other will reduces the electrical stresses and dielectric losses in the cable. So this cable is beneficial than belted cables, but and this cable is mainly used up to the 33 kV applications. The next one is the separate lead sheath type cable. This type of cable is mainly means there is a separate lead in screened cable. There is a separate lead is provided for each core. So that's why the chances of core-to-core short circuit faults is reduced in this type of cable. This is mainly this type of cables is widely used up to the 66 kV applications. The next type is the HSL cables. It is the combination of screened and separate lead sheath cable. The next type is the pressure cable. The pressure cables are again divided into two types: oil pressure cables and gas pressure cables. So oil pressure cables are used mainly for submarine application above the 66 kV voltage levels, and this gas filled cables are mainly they are contains the pressurized gas. Generally, the dry nitrogen or SF6 gas are used in these gas filled cables, and this type of air is kept at a certain pressure, and it is kept in an airtight steel pipe. So this type of cables is very useful for the extra high voltage and high load current applications. Next is the construction based on insulation. So we will see in the next slide in detail the types of the power cable based on the insulation. And the last type of last classification of power cable is based on voltage. So based on voltage, low voltage, medium voltage, high voltage, and extra high voltage. In this way, the cable is categorized. So now we will see what are the types of cable according to the insulation. So first type of cable is the paper insulated cable. This type of cable is mainly used in earlier of 90s. So that's why this type of insulation is low cost and also having the high dielectric strength, but they are widely hygroscopic in nature. So that's why they are used for the smaller installation and household purposes. And this type of insulation is mainly limited up to the LV cables, low voltage cables. Next one is the paper insulated lead cover. The main disadvantages of the paper insulated cable is and widely undergoes to that moisture content and due to its hygroscopic nature. To overcome this, the paper insulated cable means for every core there is a separate lead is provided to prevent the entry of moisture in the cable and also provide the good mechanical strength. So this type of cables are widely used for the medium voltage applications, in which the lead sheet provides the corrosion protection and also the prevent entry of moisture. And this type of cables are mainly used for the medium voltage levels. The next one is the oil filled cable. The oil filled cables, this type of cables I already explained that here in the picture you can see that there is oil duct at the center of the core. So oil will be act as an insulation also, and also it will be act as a cooling purpose. The next one is the ethylene propylene rubber. So this type of insulation is having good mechanical strength. It is also durable and also having the high insulation resistance. This type of EPR cables are mainly used for the low voltage cable to medium voltage cables. And in this type of cables, a tinned copper is used to prevent the sulfur and copper reaction. Next one is the polyvinyl chloride cable. So this type of PVC insulation is having high insulation resistance. Also it is having good dielectric strength, and also it is mechanically tough. And the main advantage of PVC cable is it is inert for the alkalis and acids, so it is widely used in cement and acid factories. The PVC cable mainly it is having the bad mechanical properties. It easily undergoes to the damage due to the external pressure. So that's why this type of cables are mainly used for the LV applications and domestic purpose. Next one is the polyethylene. The polyethylene cable is having low dielectric losses than the PVC insulation, but they are sensitive to moisture under the application of high voltage. And polyethylene is having very good dielectric strength properties than the earlier insulations. So that's why it is widely used up to the mainly 66 kV applications. It is also hard in nature and it is inflexible in nature. So that's why the next type of insulation is evolved, which is called as cross-link polyethylene. So cross-link polyethylene, in which the cross-link the name is given according to the manufacturing process and type of its insulation layer constructions. So cross-link polyethylene cable is having very high temperature. It is used for the very high temperature applications mainly up to the 300 degrees centigrade, and they are also having the better aging characteristics, and it is having the less resistance to the water draining as compared to the polyethylene, and also it is having the low cracking and property. So that's why the XLP insulation is also the flame proof. So that's why XLP insulation is now widely used for the EHV transmission also. It is widely used up to the 400 kV application. The next type of insulation is the jelly filled insulation. So in which the polythene is used as the insulation, material, and the petroleum jelly is used to prevent the entry of moisture in the cable. This type of cable is widely used for the communication purpose. Next type of insulation is the compressed gas insulated cable. So as I already explained, in this type of gas pressured cables, generally dry nitrogen and SF6 gas are used. But the main disadvantages of this type of gas insulated cable is that this cable requires the more maintenance, because you have to always, I mean, it is also a costly solution because you have to maintain the air pressures in the pipes, and also there is a widely the leakage problem is also there. So that's why this is the costly solution. But these cables are very useful for the high temperature operating applications. So now we will see the construction of the cable. So generally, at the center of the any power cable, there are the conductors are provided in which the mainly aluminum and copper material are used. Mainly copper material is used for the max to max LT cables because it is very costly. The material is very costly, and aluminum is widely used. The next, there is a conductor shield or semicon layer is provided around the conductor. So it is mainly used to maintain the uniform electrical field. Also, it is used to prevent the air-filled cavities between this conductor and dielectric material like XLP or whatever insulation it is used. And also, it is used to prevent the local electrostatic discharges, which is occurring due to the field of that other metallic conductors present in nearby the cable. So the conductor shield is again provided with an insulation layer. So insulation is mainly used to separate the conductors from each other, so that the current flow through that conductor is unaffected by that other metallic conductors. The next one is the insulation is again provided with the insulation shield, or again semicon layer is provided to again maintain the uniform electrical field and to prevent the local electrostatic discharges. After that, the conductor shield, or here you can see that the copper tape shield is provided. This is mainly used to keep the electromagnetic radiation. Means it is used as a shield to keep the electromagnetic radiation, so that it will provide a leakage, provide a path for the faulty and leakage current. So it is earthed at the both the ends. Again, the filler materials are also inserted into the cable to fill the hollow spaces in the cable and maintain the uniform shape of the cable. After that, this whole assembly is provided in the inner PVC sheet. It is used to keep the all the conductors in bundle form. The next, there is a armor is provided in the outer side of the cable. So the cable armor is mainly made up of steel or aluminum conductors. But due to the magnetic properties of that steel material, it easily undergoes to the overheating. So that's why aluminum is widely used for the cable armor, making cable armor, and also it is deemed for the prevention of the going from rust, providing the rust protection. So cable armor gives the mechanical protection to the cable, and also it is used to provide keep the cable in a rigid form. The most outer layer of the cable is called as outer sheath or outer PVC sheath. So this is mainly used to give the mechanical, chemical, and electrical protection to the overall cable. And this outer layer is also it is marked with the manufacturer details, the length of the cable, and rating, etc. So now we will see what are the different causes of the faults in the cable. So first, in the picture you can see that if there at the manufacturing time, if there are voids are provided in the cable insulation, then this type of voids are undergoes to the partial discharge whenever the cable is in service. So at the working voltages, these small air voids are undergoes to the internal small discharges, and this discharge will causes in the damage of that insulation, and after a period of time, these voids are converted into a bigger fault. So also if there is a falling, there is a mechanical deformities at nearby the conductor shield. So that's why this type of this type of manufacturing defects also causes in the severe faults after a period of time. Next one is the poor workmanship during laying. So nowadays in India, so the latest cable laying techniques like pulleys and that techniques are not widely used for the installation of cables in the underground or trenches or in the trenches. So here you can see that the pictures from Delhi in which the manual cable is laid, but in this type of installation the bending radius is not properly maintained. Here in third picture you can see that the bending radius is not properly maintained. So due to that the armor of the cable is got damaged. So that's why you have to take precaution while laying of the cable, and also while sealing all these cable trenches, because at the time of sealing this type of trenches the cable is got damaged. So we have to be very careful while the laying of the cable. The next one is the external damage due to the road construction, building the infrastructure development. So that's why due to this type of external damages the cable is got damaged, and due to that the faults are occurred in the cable. The next one is the earth subsidence or landsliding. Here the picture is self-explanatory. So you can see that due to the earth subsidence, the cable is got damaged. Next one is the overloading. Here is the side picture. You can see that due to the overloading at the termination of the cable, there is a cable is totally burned at that termination due to the overloading of this cable. So due to overloading, the cable is got damaged and the faults are occurred in the cable. Next one is the sheath or armor corrosion. Due to the insulation, if the insulation of the cable got damaged from the outer layer of this PVC jacket, due to that the moisture is got entered into the cable, and due to the entry of moisture in the cable, the armor of the cable is got damaged, got corroded, and also due to this corrosion, the insulation inside the cable is after a particular period of time it is got weakened, and due to this faults are occurred in the cable. Also, due to the lightning strike and over voltage events, the cable termination and at joints mainly means because the cable joints are the most weakest point of the cable. Due to this lightning strikes and over voltage events, the cable are got faulty at the termination and joints. Next type of cause of fault is the ingress of the moisture. So due to the damage to the outer layer of the cable, the moisture is got entered into the cable, and due to the entry of this moisture in the cable, the insulation of the cable undergoes for the water draining, and this water draining is converted into the electrical trees after a period of time, because under the application of higher operating voltages, these water trees are easily converted into electrical trees, and this electrical trees causes to the breakdown of this cable. Next one is due to the aging of the cable. After a certain period of service of cable, the cable insulation is got weakened, and due to this the faults are occurred in the cable. The next type of causes of the fault is the damage caused by the termites or rodents. So this type of mainly occurs in the LT cables. So this damage will causes the fault in the cable. And last one is the poor workmanship during repairing. So at the time of repairing, if the proper care is not taken, here is the picture in which you can see that there is a weak point at the armor joint. Here is the picture of this whole picture is the picture of the straight joint in the cable. So in this you can see that if the weaker points are remained at the time of jointing, then this type of weaker points are causes into the flashover at a particular voltage level of the operating voltage level of the cable. So due to this type of flashover, the insulation at these joints are got weaker after a particular period of time, and it is converted into the faults. So now one by one we will see the types of faults according to the fault resistance. If the fault resistance is the order of the mega ohm, then the conductor is totally break, and it is called as the open circuit fault. If the fault resistance is in between the 100 kilo ohms range, then it is called as greater than 100 kilo ohms range. It is called as high resistance type of fault. If the fault resistance is less than 100 kilo ohms, then it is called as a low resistance type of faults. And if the fault resistance is between 0 to 10 ohms, then it is called as a short circuit type of or direct contact types of fault. So here in picture also you can imagine that if there is an open circuit, then the conductor is got totally open. This type of faults mainly occur due to the external damage and due to the overloading events. The conductor is totally burned, so that's why the conductor is got broken and open circuit types of faults are occurred. The next type of fault is the short circuit types of fault. In these types of fault, mainly it is categorized into the two types. First one is the core to core short circuit faults, or another one is the core to sheet type of short circuit fault. Next one is the flashing faults. As I already explained, if there is a poor workmanship during laying, poor workmanship during repairing, then due to the weaker points or weaker joints, the flashover is occurred after if you are applying this cable after a particular voltage level, the flashover is continuous flashing is occurred at this weaker point, and this continuous flashing will damages the insulation nearby it, and it will be converted into the higher fault. So that's why this type of faults is called as flashing faults. The next type of fault is the earth fault or sheet fault. Mainly the outer PVC jacket of the cable is got damaged, and the armor of the cable or the copper shield comes into contact with the earth, and that's why this type of faults is called as sheet faults. Next one is the ingress of the moisture. So if there is due to the damage to the outer PVC jacket, the moisture is got entered in the cable, and this type of moisture is got accumulated at a certain point, and this will result in the weakening of the insulation, and it will convert it into the fault. The next one is the multiple faults, means that any possible combinations between these above faults is called as a multiple fault. So now one by one we will see how we can locate the locate the faults in the underground cables. So always we have to keep in mind that we have to follow these steps one by one only. We do not have to skip any step, because if we are skipping these steps, then it will result in the maximizing the fault location times. So first step in the cable fault location is the diagnosis. So for example, let us consider if we are going to hospital, then doctor will always examine your blood pressure, your heart rate, and he first will inquire about you, that what are the symptoms you are having, what are the previous diseases you are having, and according to that he will got in conclusion that what type of disease you are suffering from, and according to that he will treat you. So same in cable fault location, we will record the what are the cable types, means what is the exact cable details. We have to note down the cable voltage ratings and other things. Also we have to note down what type of fault is occurred in the cable, and also we have to note down the approximate cable, what are the different protection equipments are operated, and according to this all data we can go to the next step. So next step we are having is the preconditioning. So in preconditioning we can keep in mind that this step is only necessary, it is used in only necessary conditions. So let us consider in the diagnosis stage, while doing the insulation resistance testing, IR testing, with the help of any measuring kit. So whenever we are doing IR test, if the IR value is continuously fluctuating between core to core or core to armor, then there might be a presence of moisture in the cable. So in this type of conditions, let us consider if it is a XLP insulation and the IR value is continuously fluctuating, then we have to apply this preconditioning techniques to remove that moisture, because we have to convert this high resistance or unstable fault condition into a stable fault, so that we can easily pre-locate or easily we can determine the exact fault location. So it is this type of step is mainly used in necessary conditions only. So next step is the pre-location. So pre-location is nothing but we are determining the exact fault location from either end of the cable. So we call that it as test end. So from test end we are calculating the approximate fault distance by using different methods. So I will explain in later slide what are the different relocation methods the scope is offering. The next one is the route tracing. So after successful pre-location, let us consider a cable having the total length of 1 kilometer, and if we found that the fault is at 300 meter, then we have to go directly to the 300 meter. We have to connect this route tracing setup to the cable, and we have to locate the near about 50 to 50 meter area about that 300 meter distance, and we have to mark that exact area. So we got a search window for locating faults in the cable. So next step we have to carry out that the pinpointing. So in pinpointing we are connecting a surge generator or thumper to the cable, and we will carry a pinpointing set, and we will locate the exact fault location in the marked area by that route tracing step. So we will locate the exact fault location by a method called as coincidence method. I will explain in this later slides. So after a successful pinpointing of exact fault location, we will go to the next step. Let us consider after the excavation of that cable at that faulty point, if we found the multiple cables in the earth or that trench, then we have to do the cable identification, because if the operating personnel will cut the wrong cable, then it may be damage to that operating personnel, or it is very hazardous. It may also cause the death of operating personnel. So that's why this cable identification is very important and very important for the safety purpose. So that's why in cable identification we will identify the exact wanted faulty cable, so that we can take it for the repairing purpose. So after a successful cable identification, we have to cut the cable, and we have to again check both the sections of that cutted cable, and again we have to go the diagnosis steps, and in diagnosis steps, if there is any further fault is there, then we have to follow these steps again. So after there is no more fault, then we have to go for the repairing. Again we have to do the diagnosis, and after the successful diagnosis, if there is no any fault after repairing also, then the line is clear for the charging. So this is all the step-by-step approach for the cable fault location. Now we will see one by one how to do this, how to carry out this cable fault location in underground cables. First, diagnosis step. So in diagnosis step, we will record what is the exact type of the cables. Means we will note down what is the voltage rating of the cable, what is the size of the cable, and what is the insulation type of the cable. So first we will note down these details. After that, we will note down the approximate length of the cable which is known to the user, or we will calculate this cable length by using the TDR method of prelocator kit. I will explain how to calculate in later slides. After that, we have to note down the cable time in service. After that, we can also note down what is the exact cause of the fault. And also we have to, if there is any protection operations or happened, according to that we can determine what is the exact cause of the fault. After that, what is the exact procedure for diagnosis? We have to disconnect the cable from both the ends. Then we have to discharge the cable with the help of a discharge rod. And after that, we have to prepare a log sheet with the help of multimeter, IR tester, and TDR instrument. So we will see one by one. So by using multimeter, we have to keep both the cable ends open, and with the help of continuity test from the one end, we can determine if there is any short circuit fault in the cable. And also by short circuiting all the cores with armor, and again if we are checking the continuity, and if we are getting the continuity, means core is okay, and if we are not getting the continuity, then there is a open circuit fault in the core. So we can note down these multimeter readings in our cable fault log sheet, so that we can determine the exact type of the fault. After that, if there is any no open circuit or short circuit fault, then we have to go for the insulation resistance testing, because if the open circuit fault and short circuit fault is not occurring in the cable, then there is a insulation failure fault, or it is called as a high resistance type of fault. So for detecting high resistance type of fault, we have to apply the higher voltages of that IR tester. So we can use mainly 5 or 10 kV 10 kV IR tester for this cable fault location. So we have to apply this IR voltage, and then we have to check the what is the exact insulation resistance value, and according to the insulation resistance value we have to categorize the fault according to high resistance or low resistance, and we have to note down the exact faulty pair, which one is core to core or core to armor. So according to that we can we have to note down this all values for the core to core, all possible combinations of core to core and core to sheet. After that, we have to note down the we have to do the TDR testing, in which we will note down the exact cable length and also the joints location in the cable log sheet. So after successful diagnosis, we have to go for the preconditioning. So in diagnosis stage, if we are found that the IR value is continuously fluctuating between any core to core or core to armor, then there is a presence of moisture in that core to core or core to armor. So according to, if there is a this type of unstable conditions are occurred in the cable, so we have to convert this type of this type of faults into a stable condition by the application of surging. So here in the picture, it is a surge generator or thumper in which we are applying the high voltage surges into the cable. So due to the application of surges for the 5 to 10 minutes, the moisture affected area will got heated up and the moisture will be started removing. If due to the surging the moisture is not able to remove, then we have to go for the next step. It is called as burning. So in burning, we are applying continuously DC high voltage into the cable and allow the cable to flow from a higher amount of current in terms of milliamps, so that high amount of heat is produced at that moisture affected area, so that the moisture will be removed. Here in the picture you can see that there is a cable is burning at the termination kit, in which the moisture is got entered at this point. So by application of this burning, we can also remove the moistures in the cable. And also, if due to burning also, if the moisture is not going, then we have to charge the line by connecting the fuses at one end, so that due to the application of this line charging, the fuses will trip the line because the cable is faulty. But due to this short-term line charging, the high amount of heat is produced, and due to this, the moisture is removed from the cable. So after a successful preconditioning, it is it is used for necessary conditions only. So after that, we have to carry out a pre-location. So pre-location is nothing but we are determining the exact approximate fault distance from test end, so that it will give a search window for locating the faults, and it will save us a very time, because the traditional method of surge generator, by applying the surges by surge generator and pinpointing with the help of a pinpointing set. So this type of combination will cause a very high amount of time for cable fault location. So this pre-location is very helpful to reduce the cable fault location time. So in pre-location, there are mainly two types. It is categorized into two types. First one is the low voltage method. So mainly low voltage method consists TDR method. TDR means time domain reflectometer method. I will explain in later slide in detail. This is this low voltage method. The next one is the next type of prelocation is the high voltage prelocation, in which it is again categorized in secondary impulse method or multiple impulse method, or also it is called as arc reflection method. The next method is the impulse current method, and third one is the voltage decay method. So now one by one we will see this prelocation method. So first one is the in low voltage method. First one is the time domain reflectometry method, in which this TDR method is work same as the radar principle. Mainly in this animation you can see that this radar principle operates on that it will calculate the time difference between transmitted signal and received signal, and the velocity of this incident signal is set, so that according to this distance is equal to velocity of transmitted signal into the time difference between this transmitted signal and incident signal, the length distance to the object is calculated. So same principle we are operating in the cable fault locations also, but in this cable fault location we are applying a low voltage high frequency pulse into the cable, and this pulse will be returned back towards the instrument from wherever there is a change in the impedance is occurred.
So how this change will impedance in upper? Let us consider if there is a conductor is got open circuited, means the characteristic impedance of cable is got increased due to the open circuit. So this impedance changes at the this open circuit. So whenever there is an open circuit in between the cable, so that the signal will returns from that open circuit or short circuit fault point. So in this animation, you can see that the signal is got transmitted from that fault point. So according to this incident pulse signal and the received pulse signal, this prelocator instrument will measure the time difference between these two both signals, and according to the distance is equal to velocity into the time, it will calculate to the exact fault distance or the exact cable length. So scope is having max 256 kilometer range TDR. So after later slides, we will see the one by one what are the different prelocator ranges are available, which are offered by the scope. So TDR, we will see one by one the graphs. The first one, let us consider the cable is healthy, and if you are applying the TDR pulse into the cable, so this is the incident pulse, and the signal will travel towards the end, and at the end it is open circuited. So that's why there is a positive amplitude is got reflected in the prelocator instrument, so that we will set the cursors between the starting point and the starting of this positive amplitude, so that we will get a total cable length. The next one is the open circuit fault. So let us consider the cable is got completely open at this fault point. So whenever we are applying a TDR pulse into the cable, so there is at this point the impedance changes because it is open circuited. So that's why the pulse is returned back towards the instrument and graph is plotted on the instrument screen. So by setting the first cursor as incident signal and another is at the open circuited end, so we can easily detect the open circuit fault distance. So in this type of fault, the signal will not travels afterwards. This means beyond this point because the cable is got completely open. So that we can easily conclude this is open circuit fault. Because if we will short circuit this, these two, let us consider this Y2 armor. So if we will short circuit this and we will check, then we can also got to know that this open circuited end is not the second end; it is a fault end. So next one is the partial open circuit fault. So in partial open circuit fault, here you can see that if there is some of the strands of the conductor is got open, so due to this, a small positive amplitude is got reflected into the graph, and by placing the cursor according to the shown here, so we can easily calculate the partial open circuit fault distance. The next one is the low resistance or short circuit type nature of fault. So whenever there is a contact comes between the conductor to conductor, so here in the picture it is showing V2 armor. So whenever there is a contact type of faults occur in the cable, so that there is a negative amplitude signal is got reflected in the TDR graph, so that by setting the cursors according to shown here, we can easily calculate the short circuit fault distance. The next one is the cable joints. So whenever there is a joints in the cable, a small sine wave type reflection is got reflected into the TDR graphs. So by placing the cursor, we can easily know the joints locations in the cable. The next one is the ingress of moisture in the cable. So whenever there is an ingress of moisture in the cable, so the impedance of the cable is got irregular or it is non-linear type of in nature because due to the presence of moisture in the cable. So due to this irregular impedance, the TDR pulse is got disturbed, and this type of unstable reflections are appeared in the TDR waveform. So by placing the cursor like this, we can easily detect the starting point of this moisture affected area. So these are all about the TDR graphs can do. So by using TDR graphs, we can easily locate the open circuit fault, short circuit faults, but the low voltage source of this prelocator instrument is not enough for locating the faults in the means that insulation failure type of faults, because due to the weakening of insulation, there is no exact physical contact between these conductors, but the insulation is got weakened. So due to this type of condition, we cannot locate this type of faults with this low voltage source of prelocator instrument, because the signal will be easily passed through the conductors. So for this type of insulation failure or high resistance type of fault, we have to go for the next high voltage pre-location method. So in which first is secondary impulse method or multiple impulse method. So let us consider a cable of which the armor is grounded at both ends. So for secondary impulse method or multiple impulse method, we will require mainly three instruments. The first one is the surge generator. So scope is having 16 kV surge generator and 32 kV surge generator. So in surge generator, first we will connect it. We will provide master rating to surge generator, and here another instrument is called as a secondary impulse filter. So I will explain one by one what are the function of these kits. So surge generator will apply a high voltage surge into the cable, and due to the application means this surge generator is apply the high voltage surge for a particular milli or microsecond. So that's due to this higher amount of surge, application of this higher amount of surge into the cable, the at the fault point the weaker insulation is got broke down, and due to this spark is created at that fault point. So means there is momentary short circuit is created due to the application of surge into the cable. So the next one is the seam filter. So first we have to connect the surge generator to seam filter, and seam filter is connected to the connector between the faulty core and armor. So here let us consider the B phase is faulty with respect to the armor, means we got the IR value is very weak in terms of kilo ohms while in diagnosis stage. So that we have to connect in this way for the secondary impulse method. So in this type of pre-location method, we have to connect the prelocator. So in scope instruments, you have to connect the prelocator to seam filter and this surge generator. So whenever we are applying the high voltage, means first prelocator will send a TDR pulse, and this TDR pulse is easily travel through the B phase, and the graph is plotted on the screen. So whenever we will apply a surges into the cable, so that at the fault point there is a momentarily short circuit will appear, and due to this momentarily short circuit at this weaker fault point, there is a momentarily short circuit is created, and at the same time prelocator will again send a TDR pulse, so that this TDR pulse will travel back from this momentarily short circuit or momentarily arc produced at the fault point, and this TDR pulse is again returned to the prelocator instrument, and it is plotted on the prelocator screen. So here you can see that there is another graph is plotted in which the fault point is plotted as a short circuit fault, because we are converting the high resistance fault into the low resistance fault by applying the very high voltage surge into the cable, so that the high resistance fault is converted into low resistance fault. So mainly the seam filter will act as a isolation between this high voltage part and the low voltage TDR pulse of that instrument. So the seam filter will also do another job of it will extend this arc duration. So seam filter will mainly used for the two purposes. So scope scope is offers this cable fault seam filter. It is the model number is CFL SIMF. So this seam filter will holds the arc for the 20 milliseconds, and it is rated up to the 35 kV negative polarity. So this seam filter is very useful for locating the cable faults in the cables up to the 132 kV levels. So next, the main disadvantages of secondary impulse method is, so here we can set the cursors to that starting point, and there is a downward peak is at the fault point. So by placing the cursors, we can easily calculate the fault distance. The main disadvantages of secondary impulse method is that if the cable armor is got corroded or it is got broken, so that the TDR pulse return TDR pulse signals are got damped into the armor. So that's why we will not get proper TDR reflected signals in secondary impulse method if there is a corroded armor is present in the cable. So to overcome this type of limitations, we have the another method. It is called as the impulse current method. But the main advantages of secondary impulse method is that it is very accurate due to that, because we are applying the low voltage surges. So it is very accurate in nature. But impulse current method is very useful for the longer cables. So we will see now how to carry out this impulse current method. So in which, let us consider cable which is grounded from the both ends, and surge generator is connected between the faulty core to armor. So surge generator, the prelocator is connected to this cable setup through this current coupler. So now whenever we are apply the high voltage surge from the surge generator, so at the fault point there is a momentarily short circuit will produces. So due to this momentarily short circuit, a current transient is got produced into the cable. So here you can again see that. So a current transient is produced and it will be travel back towards the instrument. And these current transients are captured by this current coupler and it is sent to the prelocator. So here prelocator will act as a an oscilloscope. So mainly the prelocator will not send any signal into the cable. So this type of method is called as the impulse current method, in which if we have placed the cursor, so here it is the downward peak, it is due to this momentary short circuit at the fault point, and if we place the cursor at this hump created at this point, so it is nothing but your discharge assembly of this surge generator. So by placing the cursors, you can easily get the fault distance. The impulse current method is very useful if the it will also work in the improper conditions of this armor. So that impulse current method is very useful and accurate if the cables are in longer ranges. So now we will see the next method of high voltage of prelocation. Next method is called as voltage decay method. So scopes for the prelocators are most all of the prelocators are having the impulse current method as a by default TDRM impulse current method, so, and the voltage decay method and the ARM methods are available in the few kits only. So now we will see what is the voltage decay method. So in certain conditions, mainly in India, the cable fault location manufacturers are manufacturing the surge generators of up to 32 kV levels only. So whenever let us consider there is a very small insulation failure is occurred in the cables, it is called as a pin hair type of puncture or insulation puncture. So this type of cables are having very low leakage current through it. So this type of very high resistance type of faults will not undergo verily by the application of this 32 kV surge generator. So this type of faults are having the very high breakdown voltage than the rating of surge generator. So that's why we have, if this type of very rarely faults are occurred in the cable, then we have to use a DC high pot or a continuous DC high voltage stage set. So in which we will increase continuously the DC high voltage into the cable. So let us consider the DC high pot. We have to first provide a master earthing, and if we let us consider it is connected to the faulty cable with the help of this voltage coupler. So whenever we will increase the DC high pot, DC voltage through this high pot, then at the fault point, so this is the charging current of charging voltage of this high pot, and at the particular level the fault is got broke down and the voltage is tripped from this DC high pot. But during this application of DC high pot, the cable is got charged and it will discharge here, as you can see that it will discharge within itself. So the voltage transients will travels from this fault point towards the instrument, and again it will be travels forth and back towards the fault point. So due to this type of voltage transients formation, these voltage transients are captured by this voltage coupler, and it will be reflected on the prelocator screen. So by easily placing the cursor between these successive crescent interrupt, we can easily prelocate the very high resistant nature type of faults. So voltage decay method is we have to use this type of method in last condition only. First we have to always go through this ARM or SIN method or ISIN method. And if we are not getting after the application of maximum 32 kV or maximum 16 kV surges from the cable, then we have to go for this voltage decay method for the prelocation purpose. So this is all about the prelocation method. So we will see the overview of this prelocation method, in which the TDR is mainly used for the locating open circuit, short circuit faults in the cable, and also the detection of moisture ingress affected area. The secondary impulse method is mainly used for the high resistance and flashing type of faults, but it will not be useful if the armor conditions are not proper. The impulse current method is very useful for the longer cables, and also it is it will also works in the improper conditions of armor. So this type of method is used for the locating the high resistance and flashing fault, and this type of method is generally preferred for the longer cables. So last method of the relocation is the voltage decay method, in which the DC high power source is used, and in which we will continuously charge the cable with DC high voltage, and we will check after a particular time the cable is got charged and fault is broken. So in voltage decay method, it will also useful for the locating the HV flashing faults where very small leakage current or very high resistance fault type is present there. Last pre-location method is burn down plus ICM or SIM. So let us consider if there is moisture present in the cable. So as I already explained you, at the preconditioning stage, we have to go for the burning or searching, and after that we have to do this ICM or SIM so that we can easily locate the wet faults. This is all about the pre-location. Now we will see one by one how to locate the exact route of the cable. So for cable route tracing, let us consider a cable. So scope is offering this audio generator. It is called as audio frequency generator. So scope is offering CFL AG2, which is a 20 watt powerful audio generator, which is connected between one of the core, which is continuous towards the end, and this core is earth at the both end, and the return path of this audio generator is connected to the earth. So this audio generator is nothing but it is injecting a sinusoidal signal which is having a very high frequency in kilohertz. So this type of signals are injected into the cable, and this path is completed through the earth. So the all current will flow from this cable only. So that let us consider if we are injecting this AC sinusoidal very high frequency signal, so that due to this alternating magnetic field is created around the cable. So now look from this view. So this is all about the function of this cable called audio generator. So audio generator will send the audio frequencies into the cable. Now we have to receive these signals to locate the exact route of the cable. So let us consider this is a cable lay, in which this is the receiver. This is called as a root tracer sensor or search coil, in which we will detect this magnetic field using this search coil, and this magnetic field is displayed on the display of this cable fault root tracer receiver. So on this receiver, the signal is got plotted. So here we are sending the sinusoidal signal. So that's why let us consider if we are sending the 1 kilohertz signal. So it is plotted. It will show the exact frequency of that signal and the exact nature of the signal. So whenever the sensor is at the exact above the cable, the maximum amplitude of the root tracing space got appeared in this acoustic channel, or it is called as the root tracing channel. And this type of acoustic graphs are having maximum whenever the sensor is above the cable. So let us consider if we move the sensor either towards the right or the left. So whenever we are moving away from the cable, the signal is got weakened, the amplitude is got lowered, and so in this receiver we have also provided a headphone jack. Means we have provided headphones. So in these headphones you can easily listen this 1 kilohertz or whatever the signals are transmitted by this audio generator into the cable, and these signals are also heard by that headphones. So you can, by hearing the maximum sound and this maximum amplitude present at the this screen, it will indicate that you are at the exact above the cable, and whenever you are moving away from the cable, this volume of the audio signals are got lowered, and also the amplitudes is got reduced. So by detecting the maximum amplitudes and maximum sound, you can easily locate the route of the cable. So you have to mark this route by using this root tracer system offered by the Scope team. So Scope is offering mainly two types of receivers. So we are having two models. First one is the CFL PP3 and CFL PP3 Plus. I will explain in later slides what is the advantages of these kits, because these types of kits are scope is only offering that this type of universal receivers which is used for the route tracing purpose, and the fourth step of cable fault location which is called as pinpointing. So this uniform route tracer, universal route tracer cum pinpointer receivers are used for the both route tracing and pinpointing purpose. So after successful route tracing, you have to remove that audio generator and you have to connect the surge generator. So whenever, let us consider this is a faulty cable in which you have to connect the audio generator, surge generator. So surge generator will apply the high voltage surges after a certain interval which is set by this surge generator instrument. So scope is providing timer for applying the surges into this cable, so that these surges are applied into the cable, and due to the application of surges, a constant magnetic field is means whenever the surge will travel from one end to other end, there is a magnetic field is produced, and also at the fault point, due to its weaker points or weaker insulation levels, this high voltage will cause the breakdown at the fault point. So let us consider this, we are applying surges. So at the fault point, it is got broke. So this fault is due to the breakdown of this fault, the air void of this at this weaker insulation is got broke down, and this due to the breakdown, there is a sound waves are produced. So this type of sound are called as a thumping sound. So this thumping sound is produced at the fault point, and this thumping sound is comes towards the earth surface. Now we will detect this magnetic field and this acoustic sounds at the fault point, so that we are plotting these two signals at the pinpointing receiver. So here you can see that this is the magnetic, it will show the magnetic graphs and the acoustic graphs. So let us consider if we are very far from the fault location, then we will not get any acoustic signal, because sound will not travels, sound will travels only 2 to 3 meters vicinity of this fault point. So that if we are very away from the fault point, then the acoustic channel or the audio channel will not show any graphs, but the magnetic signals will be available. So that by whenever we are far from the fault, we will not get any acoustic signals. And also we have here provided the headphones for the listening of this fault breakdown sound, so that we can easily pinpoint the fault location. So let us consider if the user is moving towards near the fault. So whenever the user is near to the fault, the acoustic signals are starting received by this receiver, so that we can easily got to know that we are moving towards the exact fault location. So whenever we are present exact above the fault, then this magnetic signal, whatever which is present after the application of surge, and the acoustic signal produced at the fault point, they are having very minimum delay, so that these two graphs are starting from the exact zero position. So this type of phenomenon is called as the exact coincidence of this magnetic and acoustic signals. So this method is called as a coincidence method. So whenever there is a exact coincidence or very low delay between these two signals, it is called as the exact fault point. So by using this thumping sound, maximum thumping sound at the fault point, and this coincidence of these graphs, we can easily pinpoint the exact fault location by using scope instruments. So now this is all about the insulation failure or high resistance type of fault. Now we will see pinpointing of low resistance fault. So let us consider if the direct short circuit faults, or 0 to means the fault resistance is 0 to 10 ohm, means direct contact between conductor to conductor. So whenever this type of faults are present in the cable, so that we cannot apply the high voltage surges, because if we apply the surges from surge generator, then first we will not get any sound from the fault point due to the very low resistance. So there is no application for pinpointing of this type of such faults by using the surge generator. Also, due to the application of surge generator to their short circuit faults, it may cause the failure of the cable also, and also it might damage to the instrument. So if this type of faults are present in the cable, you do not have to apply the high voltage surges from surge generator. So next one is next for this type of faults,
we can pinpoint this type of faults using Scope's audio generator. So Scope is offering CFL AG2 in which we have to connect. Let us consider there is a Y phase and B phase we got short circuited at this point. So we have to connect this audio generator between these two cores so that the current will flow from this fault point, and current will not be transmitted beyond this point because this point is got short circuited. So all current will be returned from this fault point only. So whenever we will travel, we will connect this root tracing sensor to the root tracing receiver, so that whenever we will walk on the route of the cable, so we will got the cable root tracing signal on the screen. And if whenever we will reach to the exact fault point, we will get the maximum signals on the screen, and the all current is returned from these fault points, and it will not travel beyond this point. So that's why we will not get any signals after a 1 or 2 meters from fault location. The audio signals are got eliminated, so that we can easily determine that the maximum signal, whatever last point we are getting, it is called as a fault point. So by this way, we can easily pinpoint the low resistance type of faults by using Scope's audio generator and tracer receiver instruments. Now, there is also one feature we are providing with the help of while pinpointing. Let us consider if we are using the pinpointer set along with the pinpointing sensor. Let us consider this is a faulty cable in which we have connected the surge generator for pinpointing high resistance. So whenever we have whenever we are apply the surges into the cable, a magnetic field, as I already explained, magnetic field is produced around the cable. So let us consider this is the cable and around which a magnetic field is produced due to the application of surges. So it will create a constant magnetic field. So at the one side of the cable, the magnetic field is positive in nature, and at the another side it will be negative in nature. So while pinpointing, user may got distracted from the cable route or may confused while walking on the route. So Scope's pinpointers are having a arrow indications or route guidance feature. It will help user to walk on the cable route while pinpointing. It will not give you the exact route, but it will help you to walk around the cable path, so that you can easily pinpoint the fault by looking the acoustic sounds and acoustic graphs on the display. So how it will work, we will see here. So let us consider this is cable around which a magnetic field is produced. So let us consider if the sensor is placed at the left side of the cable, so that the display will show a magnetic field which is positive in nature. And here at the corner, you can easily see that there is a sensor position. At the center, it is the cable position, and it is suggesting you to move the sensor for the next step at the right side of the cable. So you have to always put that sensor in successive manner of right, left, so that you can walk on the route of the cable. So in this way, the route guidance feature is provided in the pinpointing set. So let us consider if the sensor is placed at the right hand side of the cable, so it will show a negative polarity, and also the sensor position, it will show the sensor position and also the arrow indication for the next step, next sensor position. So whenever the sensor is at the center of the means exact above the cable, so the magnetic field is got continuously positive negative will be changes. So whenever the both the fluxes are cutted by this sensor, so that it will be show the alternating graphs. So in this way we can determine the sensor position while walking or while pinpointing. So this is all about the pinpointing procedure. Now after a successful pinpointing of the exact fault location of the cable, then we have to go for the cable identification system. So cable identification, I have already explained, it is very necessary if there are multiple cables are present at the fault point after excavation of earth or after opening cable trenches, so that the cable identification will ensure user he can easily cut the dead faulty cable whatever we are searching. So for this type of, let us consider these are 3 cables are present at the trenches, in which the middle one is the faulty one and which one we have to cut. So at this trench, if we found these 3 cables,
then we have to identify the exact our wanted cable. So we have to connect a cable identification transmitter at the one end of the cable. So we have to connect this red terminal to the one of the core, and we have to ground this same core at the another end, so that the current will travel from this core only, and it will be returned through the earth path and other armor of the cable, so that the forward direction current will be flowing from this wanted cable, and in other cables the current will flow in reverse direction, so that whenever we will see a current clamp which is directed away from the source, so that let us consider if we connect to the any unwanted cable, then it will current will flow in reverse direction, so that our CFL CIS receiver, means cable fault locator, cable identification system receiver, will show you the red indications, red LEDs, so that you can identify this is an unwanted cable. Whenever if you connect it to the wanted cable, then current is flowing in a forward direction to this current clamp, so that it will show you the green indication, this is your wanted cable. And for all other dead or live unwanted cables, it will show you the red indication, so that you can easily distinguish between the wanted dead cable and other cables. So this is all about the cable identification. So after successful cable identification system, we have to go for the repairing. So first you have to cut the cable, means you have to cut the faulty section. So before cutting the faulty section, you have to discharge the cable. You have to remove all the surge generator and other high voltage connections, and then you have to cut the cable. So after cutting out cable, you will have the two cable section in your hand. So these two cable sections, you have to again go for the diagnosis step, in which you have to again check the whether there is another faults or present in the cable or not, because there might be multiple faults will be present in the cable. So you have to identify whether there is a further faults remaining or not. So after that, after the successful confirmation, you have to go for the repairing. So after a jointing or repairing, you have to again re-verify there is a we have to go for the post repair insulation test, so that you can confirm that there is no any fault after repairing also. And after this, if there is no any fault, then line is clear for charging. So this is all about the repair and retest. So these are the all safety precautions you have to always keep in mind that. So while testing, means while locating the cables fault using scope instruments, always you have to connect the earthing first to the all the instruments, and after connection of this earthing, then you have to connect all the test lead sets to the cable under test, and you have to at the last you have to connect the main supply to the instrument. So also you have to always put caution labels, or you have to keep an operating personnel at the other end, because if you are injecting the high voltage pulses from one end, then any other person might get come into the contact of that live conductor at the another end, so that it may got damage. So that's why you have to always put caution labels at the both ends. Always you have to put the caution labels and switch off all the switch gears, so that any person cannot switch on the switch gears accidentally, so that it because if you turn on the cable, means if you will charge the cable while operating this cable fault location instrument, then it might get damage the instrument and cable also. So always use a good quality AC supply, AC mains power, and also use a good quality earthing for this probe instrument, so that you can easily pinpoint any fault location. So this is all about the safety precaution. Always wear the helmets, HV rated hand gloves, shoes, whatever it is compulsory in your premises. So this is all about the safety precautions you have to always keep in mind. So now we will see what is the different solution available from the scope. So this is scope is having prelocator series, surge generator with, we will see one in next slides one by one is all the solution. So first, prelocator. So scope is having prelocator series, in which it is very accurate and user friendly kits in which and any unskilled operator also can easily locate with this simple operation interface provided through this prelocator kits. So in prelocators, it is very compact and rugged in nature. It is also provides the waveform comparison, automatic fault distance calculation, zoom function, and the cable library for easy setups in the cable. And also it is having inbuilt memory to store the waveforms so that this type of waveforms can be used for the future references. So this is our CFL prelocator series. So we are having six different model which offers the various prelocation methods. So we are having top end models like CFL PL3 Plus and PL4 Plus, in which you can easily detect. It is equipped with the all prelocation methods, and it is also having the measuring range of this 128 km for CFL PL3 Plus, and for CFL PL4 Plus, the scope is offering the fault distance calculation or TDR measurement or any prelocation measurement range up to 256 km. So this is all about the scope prelocator series. The next one is the scope surge generator series or CFL HG series. So scope is having two surge generator mainly. It is first one is the 16 kV surge generator. So in 16 kV surge generator, we are having 0 to 4, 0 to 8 and 0 to 16 voltage ranges. And at all these voltage ranges, scope is offering these output energy options like 500 joules, 1000, 1500 and 2000 joules. So this 16 kV surge generator with these different energy options, it can be suitable for testing from LT2 up to the 20 kV cables. So also the 16 kV surge generator is equipped with these optional modes. I will explain in later slides. DC high port, burn down and ship hold locator modes. So this is our 16 kV surge generator is equipped in means housed in an aluminum casing, which is very rigid and equipped in a transport trolley, so that you can easily move this type of kits. So this is 16 kV surge generator specs in details. You can go through it. The next one is the 32 kV surge generator. Scope is also offering the 32 kV surge generator with the 1000 joule, 1500 and 2000 joules of energy options, in which it will offer the three voltage ranges of 0 to 8 kV, 0 to 16 kV and 0 to 32 kV. The 32 kV surge generator is also having the optional modes like DC high port, DC burn down and ship hold locator mode. So this is surge generator is equipped with various safety interlocks to ensure the operating safety of operating personnel from these HV operations. Various indications are provided to indicate the healthiness of instrument and operating conditions of this instrument. Next one, this is all about the 32 kV specification. In CFL HG series, these are the different safety interlocks are provided into the surge generators to ensure the user safety, and different types of indications are provided. So this is the front panel of the 32 kV multi-mode surge generator, in which the all modes are equipped. Next one is the optional modes available in the CFL HG series. So first one is the burn down mode. As I will explain, in pre-conditioning, you have to go for the burn down for removing, means to alter the fault condition into a stable condition, so that you can easily prelocate. So scope is offering the burn down mode, which is inbuilt in the surge generator, which is an optional mode. So it is mainly, it will convert the high voltage resistance fault from this PI, means paper insulated and paper insulated lead covered cables, so that if the high resistance fault are converted into low resistance, so that it will be easily prelocated. And if there is a solid insulations like EPR or XLP cables, type of cables, so that in these types of cable, the moisture is for removing the moisture in the cable joints, the burn down mode is very useful. The next one is the DC high port mode. So in DC high port mode, mainly this type of modes is useful to check the healthiness of the insulation of this cable, so that by applying high voltage and means measuring the leakage current flowing through this connected between this core to armor, user can easily determine the healthiness of the cable insulation. This mode is equipped with the inbuilt timer, so that user can test up to the preset timer. So generally generally scope is offering the this DC high power mode up to the 24 milliampere max to max, so that user easily can check the insulation healthiness up to 24 milliampere. The next one is the sheet fault locator mode. This mode is very useful for while locating. Let us consider if there is a sheet faults or earth fault, means the outer PVC jacket of the cable is got damaged and the armor of the cable is got in contact with the earth. So the inbuilt sheet fault locator mode of the surge generator will apply the pulse the DC surges into the cable. This is a special type of DC source is required for the sheet fault location. So scope is offering up to the 8 kV DC sheet fault testing, in which by using the step voltage method, you can easily pinpoint the sheet fault with the help of this D frame. So D frame is nothing but it will work on the step voltage method, and it will locate the exact damage to that PVC outer PVC sheet of the cable. So this type of sheet faults will not affect the cable performance, but it will be after a particular period of time, these faults will be results in a severe fault. So that's why this type of mode is very useful in the cable fault location. This is all about the cable fault SG series. Now we will see the cable secondary impulse filter or CFL's SIMF, which is used for the pre-location of this secondary impulse method. So scope is offering the arc holding time up to the 20 milliseconds. So this is the pictures of this cable fault SIM filter. This is very lightweight and easily transportable. The next one is the audio generator. Audio generator mainly act as the signal transmitter for root tracing purpose, in which it is a 20 watt maximum output power, and this is having the various protections is provided, and it will give the cost stabilize the frequency so that you will not get any disturbance while root tracing. This is all about the CFL-AG2. It is very lightweight 2 kg instrument, so that you can easily transport. This is all about the CFL-AG2. Next one is the cable fault pinpointing series. So scope is having a universal receiver for root tracing and pinpointing of the fault with the help of surge generator. So that it is called as a universal receiver. So scope is having CFL-PP series with the two models, CFL-PP3 and CFL-PP3 Plus, in which the higher model is offering the detection of live loaded cables and mute functions. This advanced functions are offered. Also, it is offering the automatic fault location using coincidence method. So this is the short comparison between these two models, in which the PP3 Plus is touchscreen operated color display and advanced mute functions and other the wide frequency ranges are provided in this advanced CFL-PP3 Plus instrument. The next one, this is all about the cable fault root tracer and pinpointer series. Now we will see cable identification offered by the system offered by the scope, in which the scope is offering the cable identification system, in which the transmitter is sending the maximum current output of 100 amperes, and it is having a very flexible clamp meter, means whatever the current clamp is I had shown in the previous slide, so that this is flexible clamps can be easily inserted between any bundle, any cable, so that user can easily detect the wanted cable from a bunch of cables. This is all about the our lightweight portable cable fault identification system. The next one is the scope is also offering the other accessories like 5 kV, 10 kV insulation testers for the diagnosis purpose. Next scope is also offering the multimeters for the diagnosis purpose. Next one is the scope is offering the up to 132 kV rated discharge rod for discharging the cable entirely by using this discharge rod. The next one is the measuring wheel. Scope is offering the measuring wheel to measure the cable distance above the earth surface. Scope is also providing the barricade for the entry prohibition. If you are testing with the high voltage instrument, you can use these barricades for any unauthorized person entry to avoid. Next one is the scope is also providing earth spice for the additional arcing purpose. Scope is also having the cable fault locator van. So we are providing various, we are mounting our cable fault system on various vehicles. So this is our higher model, in which we are mounting all the cable fault system in traveler van, on which this is the high voltage section, on which we are mounting all the high voltage system. This is the operator window at which the laptops and all the operating window is provided, so that in single control panel you can operate all the instruments. Also it is equipped with the fan lights for the user convenience. Also, this fan will be equipped with a diesel generator set, so that there is no any external power supply required for the operation of this instrument. Also, it is equipped with the 50 up to 50-meter cable drum, so that user can easily connect the instruments to the cable under test by putting this fan on road itself, because it is having the 50-meter test kit set. So also it is provided with the safety interlock. You have to close this door and take out these cables from this cable duct, so that any unauthorized personnel cannot enter in this high voltage area. So that if this door is not closed, then high voltage section will not turn on. This is the various safety features also provided in this fan. This is all about the cable fault locator test fan offered by the scope. So, thank you for your kind patience. Now we can move for the question and answer session. Hello? Hello? Hello, Nilare sir?
Yeah.
Hello?
Yeah.
Sir, can we go through sir Q&A session?
Yeah, obviously. If there is any question, you can ask into the chat box. We can reply accordingly.
Also, there is a feedback form link is shared into the chat box. So you can fill this feedback form. If you are having any questions, you can put in chat so that I can reply. There is a question from Pranav Ghosh. How do we confirm whether a cable is live or not, and what are the techniques? Sir, if cable is live and it is connected to load, then it will carry a current of 50 Hz frequency. So scope is offering that root tracing receiver, in which it will also act in operate in a passive mode. It will take a 50 Hz signal, so that it can indicate if the cable is live or not. But if cable is not connected to load, then current will not flow from the cable, and we cannot determine the live condition of this type of unloaded cables. But if it is loaded, then we can detect with the help of cable fault root tracer.
However, with the help of CFL CIS, whether it is a loaded cable or not, we can understand. Instead of understanding loaded cable or unloaded cable, we can understand whether the cable which we are looking forward for, whether we are going to cut the same faulty cable only or not. So it is a reconfirmatory test, you can say. CFL CIS model with the cable identification system, we can understand that.
Okay, there is another question from Glenn. The graph of TDR is more translating the type of fault rather than the locating fault. Mr. Glenn, TDR graphs are mainly, it can indicate the open circuit fault distance and short circuit fault distance. So it is not only it is not giving the only indicating the type of fault, but it will give you the exact open circuit and short circuit distance from testing.
There is a new question from Mr. Stanzin Tolden. Which cable fault locator is best for Hertz climatic condition like Ladakh, where temperature variation is between plus 30 degrees centigrade to minus 30 degrees centigrade? A very good question, sir. Actually, the question I will like to answer in a bit different way than the normal way. Uh, when the temperature is going sub-zero, let's say -10 or beyond that, so at that time what is happening, practically we will not be able to do the testing, any sort of testing, outdoor activity. But at all, if we are wanting to do it, actually we have to check, because in India we are not having any setup where we can test any our setup beyond -10 degree. So we have tested our product up to -10 degree centigrade. So if you want to test it beyond -10 degree, that we need to check practically. Rather, all the manufacturers, whoever is offering, they are always talking about up to -10 degree centigrade. However, the special thing is that the pre-locator thing. So because in the -10 or something like that, the touchscreen displays will not be that much useful. That's the reason we do not have any touchscreen function in majority of our CFL series of product. So they can be used up to the sub-zero -10 degree. Beyond -10 degree, we need to really check, sir. Mr. Glenn has asked one more question. What is the limit of the depth of cable, buried cable, that the pinpoint locator can still detect? Vishal, you can answer.
If the ground surface is totally made up of soil, then our pinpointing instruments can locate up to the 15 feet, or it is approximately 5 meters. We can easily detect the faults having the depth of 5 meters. Okay, the next question from Glenn. Will the test equipment specifically going to indicate the location of fault in meters, inches, or feet? Yes, we are in our plus series. We are having meter, and meter or setting means our locator is indicating the fault distance in meter or feet, and other our plus PL series are having the fault distance locating in meter. So it will indicate directly in meter, not in any other units.
But depending upon the how much kilometer or the range you are selecting, based on that, it is not only the meters. The resolution of the things goes 0.1 meter or 0.01 meter on that fashion. So that is the thing, and it is actually the electrical fault distance. The actual fault distance is supposed to be a bit lesser than the electrical fault distance. The reason is that cables are generally kept in some loops, are kept out while laying the cable. So that loop distance is not coming into picture into the physical distance. So physical distance is somehow a bit lesser than the electrical distance. There is one more question from Mr. Pranav Ghosh. What if there are pipe along cables? Will pinpoint locator work? Yes, sir, it will work. There will be some disturbances, but pinpointing, yes, it will easily work. The root tracing may face some problem due to the things, but it can be with a little bit of concentration. If we are doing the root tracing and pinpointing, we can easily detect whether there is a pipeline along the system or not.
Okay, sir. So there is no further questions.
If there is no other question, we can close the session. However, if you are still want to know anything more, you can send us your queries to our email IDs. We are giving our email ID in our PPT, as well as I am typing over here. Once again.
Okay, sir. we will close the session. So thank you very much for your kind patience and attention. So we will be closing these sessions now. Thank you very
Thank
much
you.
for participating in this webinar.